Okay, hello. Good morning, good afternoon, good evening. Welcome to the networking channel, the third talk in the fall series. And today we're here for a very interesting site visit. So as you know, the networking channel has different kinds of formats, technical exchanges, technical talks, our topical areas. And today's area is around 5G. And not just 5G, but actually a real live look inside a 5G experimentation facility and in Norway as part of the 5G-VINNI European platform. My co-organizer and the MC for today is going to be Per Lehne from Telenor. He's a senior researcher and he is going to be orchestrating the session. Just wanted to go over a couple of logistics items. So question and answers, please type that in the Q&A box that should be visible to you. And you should be also able to join us on a Slack channel that the networking channel is going to host, and you'll be getting that link posted in the chat very soon. This is for Q&A, follow-ups, interacting with our panelists, asking them questions, and just staying connected after this session is over. The session's been recorded and you agreed to be here. So really appreciate it, really excited to actually see 5G in action. This is something that not a lot of people have the fortune of seeing working. 5G is still being developed, under consideration in multiple countries. So if you're joining us from different countries where 5G service is not available, this will be really key to understand the nuances, the advances, and the work that this team has done. And I really want to appreciate and give a shout out to the team at Telenor, the team at Nokia, Ericsson, as well as at the Norwegian Defense Agency. With that, Per, I'd like to hand it over to you. Please get started. Thank you.
Thank you very much, Manu, for the introduction. Let me just show you the today's program. So we're going to have 4 different talks today. First is the introduction to the 5G-VINNI platform and an overview of the standalone setup, which is being done by Andrés Gonzalez, who is a senior researcher in Telenor, and also the project manager of 5G-VINNI. Then we're going to have a demo and an explanation of how the military can use 5G. This is done by Kennet, Nomeland, who is the radio system architect from the Norwegian Defense Materiel Agency. We are following up then with the 5G standalone demo done by Johan Morten Tetlie, solution architect at Ericsson. And last but not least, a demonstration of the 5G-VINNI network slicing implementation with orchestration done by Dimitriadis, who is the lead telco cloud infrastructure and automation solution architect, and his colleague Tirthankar Ghosh, who is a solution architect in service orchestration both from Nokia. And we will end with a panel discussion. So with that, I will hand directly over to the first speaker, Andrés, please.
Thank you very much, Per. I will share my screen, and please confirm that you see my screen, Per. Right.
Very good.
Okay, let me start. So welcome, everybody. It's a pleasure for me to be here. My name is Andrés Gonzalez. I'm senior researcher in Telenor. And I'm part of the 5G-VINNI architecture team. You will see details later on what is the 5G-VINNI architecture team. And specifically in Norway, I am the architect of this facility. This is a huge work that has been, you will see the dimension of this project, and has been impossible to do this without the cooperation of our partners in this project. About 30 engineers have worked directly, and I think about 50 to 60 indirectly. So we are doing big things, and after some years of work, we have nice thing to show you. I want to start by some reflections to the audience, and I want to be a little bit provocative because it's a thing that I ask myself every day since I work with 5G, and this is my passion. So let me put you this context. When we start to work about 5G, there were many expectations, and society got very excited, industry got very excited, and we have in mind a lot of use cases. The target and the goal was huge. And this is very nice. That was a big motivation that made me so happy to work in this project. Today we have 5G, and most of you, I don't know in which country you are, but I think most of us today may have some initial offers, commercial offers of 5G. And then I asked myself something that maybe you ask also. How close are we to meet the expectations? I have to be a little bit provocative, and I have to say very openly that I still see a gap. And I hope you agree with me, and I will be very happy to contribute with some answers about some questions that you may have about it. But what is the point of this talk? 5G-VINNI is a project that shows a closer look on how 5G can meet the expectations. So, of course, there is a gap, but it's not as huge as most people may think. And there are big challenges. The target was huge, but with this presentation, especially the one that my colleagues will give, we want to give you some answers, and at least you will have a more clear perspective of how big is the gap. It's really what is the current situation? Let me start by some description of 5G-VINNI. 5G-VINNI is H2020. It's an European funding project. And what is the point here? The point is that we say, okay, we need to have a platform to demonstrate the KPIs of 5G. These KPIs can be met or not. And the second objective was to enable vertical industries to implement use cases. This is a project that lasts for 3 years, and in reality, due to COVID, is 3.5 years. And it's 23 partners working together. And as you see, all the names of the 5G-VINNI, all the partners are here. And we have presence in many countries in Europe. So talking about all these details in whole Europe is very difficult. So the point of this talk is more on the Norway facility, but the architecture is, we are part of an architectural team that is very well synchronized in all the facilities in Europe. But when it comes to the Norwegian facility, there are some services that we want to highlight, and I don't have time to go through all of these in detail, but I hope maybe into some questions. But we provide slicing. You will see later more in detail what we mean with the slices. We have the enhanced mobile broadband slice, ultra-reliable low latency communication, machine and IoT, and we have customized slice. And we have in addition value service like monitoring as a service, testing as a service, security as a service that I'm not sure I haven't seen much similar approach, and this is very interesting. Third-party VNF hosting, distributed data fabric, edge and autonomous edge, which is a very important detail. One thing is edge, other thing is an autonomous edge. Flexible backhaul for redundancy and interconnection with other 5G sites. It's huge. Maybe I have time to some questions at the end. Let me go a little bit into the details of 5G-VINNI. I told you that it's more about than 20 engineers, 30, and external indirectly several that have helped us. This big project has not been possible with the help from Ericsson, Nokia, Huawei, Keysight, Palo Alto. So a lot of engineers working with us. And as you see here, what is 5G-VINNI? 5G-VINNI is composed by base stations, by a transport network that allows to have presence all around Norway, by a core network where Nokia provide the beam and the VNFs from the core functions are from Ericsson, and an end-to-end orchestration automation system from Nokia that you will see in action later. We have presence in Norway due to the transport network that we have. We can basically still run all across Norway, no problem. And something that is very important, we have infrastructure, but we have also use cases through some other cooperations, other projects, as you can see here. And that gives us first-hand insight on how to use 5G in order to close this gap that I mentioned at the beginning in a very provocative way. Basically, this is also a slide that may contain so much information, but I just want to highlight what is a slice. And in 5G-VINNI completely, we have 5 slices, 3 non-standalone and 2 in a standalone. This, we have the RAN in this side, as you see here, and we have several functions in the core. But let me go one by one. First of all, I want to highlight key concepts, because talk about everything in 5G will take me too much time. But one first key concept here is that 5G is about having new RAN and having 5G core. This is fundamental and is the fundamental building block of 5G. RAN allows faster networks, and the core is fundamental to support most of the features we have. In addition, 5G is about a cloud-based architecture. And I want to show you this. Automation is fundamental to take advantage of 5G. Why we have this cloud? Basically to do this thing as you see in the slide. It may look like an animation, but in fact, what Antonio and my Nokia colleagues will show you is that this is real. And I have myself struggled a little bit at the beginning of the project doing some of this thing in a manual way. And through the scope of the project, to the ratio of the project, we have managed to make this thing just as this slide shows. We push the button and we are able to deploy not only VNF, but also automate secure implementation of security roles. So automation is a key concept too. And to be honest, if I want to target the gap that we have, we need key verticals like Norwegian defense or public safety verticals that give us enormous good feedback of what they need, and we try to deliver that best. You will see later with Kennet this approach. So my conclusion is, yes, we have a gap, but VINNI is here, and this presentation is this arena to go deep, and this is not an uncomfortable question. Let's talk openly how big is this gap and how close we are to make these expectations. How? Norwegian Defense will present you something very concrete on what they have achieved by the use of 5G-VINNI. My colleagues from Ericsson will show you the advantage. I mean, the fundamental piece, there is no 5G if there is not 5G RAN and 5G core. This will be explained in detail. And finally, why to put a new architecture that revolutionary with the cloud? Basically, because we need to automate. There are many nice things that we do here in automation, and my colleagues from Nokia will present you that. So I give you an overall scope here, and I hope with the next presentations, you go deeper with these 3 fundamental points that I described here, and I hope to receive many questions at the end. So thank you very much, and I pass the voice to you, Per.
Thank you very much, Andrés, for your introduction. We'll save the questions for the Q&A session as we agreed on, and without spending more time for me, I will just hand over to Kennet Nomeland, a radio system architect from the Norwegian Defense Materiel Agency, who will talk about the use cases for the military use of 5G. So please take it away, Kennet.
Thank you very much, Per. I hope you can both see me and hear me now.
We can.
That's good. So my name is Kennet Nomeland, and I work as a radio system architect in the Norwegian Defense Materiel Agency. We are the one providing all the equipment for the Norwegian Armed Forces, everything from F-35 to submarines and also ICT equipment. And on behalf of the Norwegian Defense, I am today coordinating 2 5G pilots, and I will share information of how the Norwegian Defense, through these pilots, is trying to adapt 5G to military use. So I will talk about 5G, but just to be clear, no military organization or the Norwegian Defense will put all their eggs in one basket when it comes to communication. We need many tools in our toolbox and use them depending on the scenario. But our goal is to increase the security in the 5G networks, both the public and the private networks. So it is suitable for military use in most scenarios. The use of 5G opens up many new possibilities. IoT, artificial intelligence, and machine learning is tight connected to this ecosystem when 5G and cloud technology is merging, and the military needs to take advantage of this. Now, 5G is very complex, and a broad collaboration is necessary to succeed. So when the cloud extends to the 5G edge, you need both experts in cloud technology, 5G, radio, and security. And in addition to Telenor research, we are also working with the Norwegian Defense Research Establishment and Norwegian National Security Authority to secure the value chain. In 2018, we joined this EU-funded 5G-VINNI project led by Telenor Research. And in this vertical innovation infrastructure, or VINNI, the goal is to adapt 5G to different verticals, like my vertical. And last year, we started up a second EU-funded pilot called 5G together with Telenor Research. In this pilot, we are exploring use of private 5G networks. And this pilot is running until February 23. Now, I will show you also a bit combination of why I'm talking about that as well, because we see private networks, something that comes in addition to the slicing in the nationwide networks. So our 5G pilots is not about evaluating products and applications. It's all about concepts and architecture. We do not want to build a new silo system. We want to design a model or a concept and architecture where we can offer hundreds of applications and services in the future. And the learning curve is extremely steep. Here is a promo video of what we are doing in 5G-VINNI.
5G-VINNI is a European research and innovation project that is building a large-scale, end-to-end 5G facility across Europe. This facility is a platform used by vertical industries such as healthcare and manufacturing to test use cases and validate 5G key performance indicators. In Norway, Telenor hosts the 5G-VINNI testing platform along with Ericsson, Nokia, and Huawei. Palo Alto supports on security, Keysight on testing tools, while Cisco provides the IoT data fabric. The 5G base stations use new frequencies, such as millimeter wave, which are positioned at Fornebu and across Norway. Our open multi-vendor cloud platform hosts the 5G core networks and enables easy onboarding of customer applications. We have already implemented isolated 5G networks called slices, using both 5G standalone and non-standalone. These slices are being used in various ways by vertical industry partners. One such partner is the Norwegian Defense. The 5G-VINNI site in Riga is where we host the use cases for the Norwegian Defense, such as gunshot detection and drone control. 5G-VINNI has provisioned a dedicated slice for the Norwegian Defense. The Riga site consists of both C-band and millimeter wave 5G radios, along with satellite for backup transport connectivity. This site is also equipped with an edge data center.
We are excited to work with Telenor Research in the 5G-VINNI project, as this allows us to experiment with innovative technologies which are not available in the commercial networks, like 5G standalone and network slicing.
We are exploring with the Norwegian Defense how to gain instant situational awareness by applying machine learning on multiple video streams in the edge cloud.
I'll stop there. So at Rygge Military Air Base, we built a 5G test facility last year. And in this pilot facility, we have actually 890 megahertz of spectrum available, including C-band and millimeter wave support. We have an enterprise edge with full 5G core, plus military services running as application functions inside this edge. And we do have both fiber and satellite backhaul to this military airbase. During last winter, we tested out range, capacity, and robustness, or jamming, in different frequency bands at Rygge Air Base in the 5G-VINNI network. In the FUDGE pilot, we are exploring use of a standalone private 5G networks. A complete 5G standalone network, including radio and edge, plus core, of course, and edge with military services, is placed inside a trailer, as you can see in here, that we can bring with us wherever we want to go. We call it a cell on wheels, and we have dedicated spectrum, and we can offer gigabit speed. The private network has been used in multiple use cases. Here are some pictures a couple of weeks ago when we were up in the north and testing interference towards radar systems. At the moment, we are also experimenting how to get a higher uplink capacity, for instance, to transfer high quality video uplink from cameras or drones by, for instance, changing the TDD frame structure. So at the moment, we have two separate test networks available. This fixed network, the 5G-VINNI, in this military base, and this mobile fudge 5G network, as you just saw in the video. And in these two pilots, we are addressing what traditionally has been difficult with the 3GPP-based communication seen with military eyes. For instance, electronic warfare or jamming, IMSI catching, and the lack of autonomy, and how we now can mitigate these threats in 5G. Together with Telenor Research, we have designed a dedicated defense network slice that is totally separated from the commercial traffic and adjusted to our operational needs with focus on security and necessary functionality. Regular EMBB users, as seen on top here, will have access to internet, social media, roaming abroad with all the possibilities, but also all the threats. The defense network slice, as seen on the bottom here, is designed for a totally different need. Users are not connected to the internet, but to a closed military ecosystem with access to military services and trusted partners only, as I've tried to illustrate on this slide. Our goal is a network-based defense where our combat net radios with 5G modems, IoT sensors, and smart devices can give us a much more efficient defense in the future. The defense network slice is increasing the security and connecting our military clouds on the right-hand side here via the 5G network to the tactical edge. Now let's talk about autonomy. Because of edge computing in 5G and private 5G networks, it is now possible to achieve autonomy closer to the end user. Some locations are very strategic and will not move even in a war, such as a military airport. An enterprise edge can be set up in a strategic important area for us. And in Rygge military airport, we are testing out this edge concept. In the 5G-VINNI, the 5G core runs in the main data center in Oslo, as you can see on top here. And in addition, we run a full 5G core plus third-party application in our defense network slice, so-called application functions, in the enterprise edge in Rygge Air Base. So even with a transmission failure of both fiber and satellite communication, we can still offer services locally via the 5G base station, wireless in the airport area. Now that was enterprise edge in a strategic important area. Now let's talk about use of private 5G networks. So in this fudge 5G pilot, we are testing out private 5G networks, as you can see on the left-hand side here. And from a telecom perspective, we will test out different ways of using both a private and a public network. So when this guy in the left-hand side here is moving outside his bubble, he should still be able to utilize a public network. And there are several ways of doing this, for instance, by using different SIM profiles. That was from a telco perspective. But from a service perspective, we want to find out how we can utilize centralized clouds, 5G and edge to create better and more robust services. As I have to try to illustrate here, it is now possible to spin up the backend component of your service in your centralized military clouds on the right here as application functions inside your network slice in the 5G network directly, or on your private 5G network as seen on the left-hand side here. And despite downtime on transmission, it is still possible to design the service to be much more robust. These days, we are thinking a lot of how the architecture should be. And part of this equation is also factors like dependencies to the MNO and flexibility for the defense. We want to be vendor or operator agnostic. Security level of the services, for instance, only classified services in the edge and in the military cloud, and the use in peacetime, crisis, and war. I will give you some example of what concepts we are testing out. In the VINNI pilot, we test out a traditional push-to-talk service in the defense network slice. The PTT backend is, in this scenario, an application function running in the 5G VINNI cloud in Oslo and inside the enterprise edge at Rygge. We get the PTT service directly from the 5G network. We just need a SIM, including regional autonomy at Rygge. But this kind of setup is done in a close cooperation with the MNO. Our defense network slice is running on their infrastructure. We will also test out the PTT in the fudge pilot. And in that use case, the backend runs locally in the edge in a private 5G network, but also centralized in a military cloud. And the PTT speech groups are being synchronized when there is a connection, for instance, via satellite communication or via our defense slice in the nationwide mobile networks. In this setup, we don't have to be so tight connected to the MNO, and the defense can have more ownership in the value chain and just use the defense slice in the MNO nationwide network for secure IP transport. And through the pilots, we will learn more what is most suitable for the Norwegian defense. I will give you one more example of how we can utilize centralized clouds, 5G and edge to create better and more robust services. In this use case, we are testing out a gunshot detection system where every soldier becomes a sensor with his smartphone. When you have at least 3 smartphones, you need to have at least 3 smartphones that listens for gunshots. So when the application detects a gunshot, it should immediately display in a map where the shot came from, the angle of the shot, plus what weapon type was shooting. Was it our gun or an enemy gun? And how is this possible? The gunshot acoustic signature is converted into a graphical image and tagged with precise time and position. And with the speed of 5G, the data is sent to a military cloud, which do 2 things. Number 1, correlate time and place of the gunshot data from the smartphones to find the exact position and angle of the shot. And number 2, finding a match in a library of millions of graphical gunshot images. The centralized database is all the time updating its library, taking away false positives, and improving the algorithms. The local edge is updated with the newest gunshot library and algorithms. So if there is no connection to the centralized cloud, the GDS system will still work locally in the edge. 5G drone control is also something we are testing out in our pilots. Our drones are 5G enabled and can be remote operated beyond line of sight via the 5G network. The video stream from the drone can be distributed via the 5G network to relevant personnel. Our partners are also working on how to get better situational awareness by applying artificial intelligence to the video stream. The drones are equipped with three different cameras, including infrared cameras. And here is also a short video of a 5G drone control demo in June in the 5G-VINNI network. The drone is flown beyond line of sight from the operator via the 5G network, and the video feed is distributed to the smartphones to relevant personnel, in this case, the personnel in the air base. Here we get the video. The goal is also to work towards GNSS independency, for instance, by use of 5G positioning or location management function. So we are working on multiple use cases at the moment, I think close to 70, but I will stop here and summarize a bit. This overview illustrates what we are trying to achieve: to offer services across centralized military clouds, the 5G network and edge nodes, both in important strategic areas via enterprise edges, as we do on Rygge Airport, as you can see on the bottom here, or out in the tactical domain via 5G, private 5G network. And by use of cloud technology and 5G, the service can be both better and more robust. And with that, I'll just end up with 5G changes everything, here represented with our 5th generation fighter plane, the F-35. That was a game changer for the Norwegian defense. Thank you for your attention.
Thank you very much, Kennet, for this introduction demonstration of the military aspects of 5G. I will just hand directly over to the next speaker. That will be Johan Morten Tetlie from Ericsson, Norway, who is the solution architect. He will guide us through a 5G standalone demo. Please, Johan Morten.
Hello, my name is Johan Morten Tetlie, working at Ericsson in Norway, and we should try to share a video today about the 5G core. Hello? Do you see me?
We can hear you and see you.
Okay, can you see my presentation?
Nope.
Okay. I have unfortunately some network issues here, not able to share. Unfortunately, I'm not able to share my content right now. It's hanging in my laptop, so try to.
Okay. So for timekeeping, maybe we could switch the order while you fix that. Antonios, Tirthankar, are you ready to take this time slot, and Johan Morten can come in after?
Yeah. I can try
Okay.
to share my slides.
So then it will be a demonstration of network slicing on the 5G-VINNI network by Antonios Dimitriadis and Tirthankar Ghosh from Nokia.
Hello, good afternoon. I'm Antonios Dimitriadis. I'm the Telco Cloud Solution Architect and also Automation in 5G-VINNI project. And together with my colleague Tirthankar Ghosh, who is Orchestration Solution Architect, we are going to show you how we achieve the network slicing automation in 5G-VINNI project. So we'll discuss about why we needed the automation, what are the benefits and why we did that one. Then how we can do it. So all the design steps that we followed and the challenge that we faced to achieve that thing. So as a first step, we need to see the slices. Here we see a number of slices that we have in 5G-VINNI project. We have the non-standalone, we have the standalone, and then we have also the defense slice, which is between different sides, the central side and the edge side. We have even more slices than this. So in a live environment, we may have 100 different slices or even more or less. And then we see that the number of VNFs are a lot. So, and then we see that they are repeated. So there is a pattern behind this. So there is a real benefit to automate that part. So with one click, because to deploy a slice manually, as also Andrés mentioned at the beginning from Telenor side, it's a big challenge. It may take weeks or even months to have one slice if you deploy it manually. But if you can automate it with one click, you can achieve the automation in some minutes. So this is what we have done already in 5G-VINNI. But to achieve that one, we need to work a lot to prepare several things in advance, and then we will be in the position to do that. So the first thing is about the templates. So we know from Mano, for example, in the HCNV architecture, we have the NFV orchestrator, we have the VNF manager, then we have the Vim where it's OpenStack or VMware based. In our case, OpenStack based Vim from Nokia, the cloud infrastructure. So to deploy a slice, we will have a number of VNFs. Those are coming from different vendors. So they have as a template, they need to prepare a specific VNFD that we need to upload in the VNF manager. So in this case, we see here the different VNFs that we have. In our case, they're coming from Ericsson, and they're responsible, for example, to prepare them. Then we go to the NFVO level, where we have the network services. So the VNF manager sees the VNFs. The network service descriptors will include a group of VNFs plus some other things that we want to create, like the networking part. And then here we see that the slices will have a number of VNFs that they are grouped already in the network services. So this is a different views that we have from the templates. So once we have a template, for example, of one NSD one, which is MMN Gateway, I can deploy this 10 times just using different input data. Then we see here the differences, and as an orchestrator, we see the slices. Once we have the templates, the next step is to see about the interfaces. Here we have a multi-vendor environment coming from different vendors. So when we talk about a network slicing deployment, we don't talk only about the VNF onboarding, but also we need to consider the networking part. All these VNFs, they need to talk to each other. So we have somehow to create those networks. So from an orchestrator point of view, we need to create the networks using the SDN solution we have here in WADS, or like in the edge side, we don't have SDN, but we use physical network devices. So also we should be in a position to go and create the new VLAN, for example, the new subnets, so the VMs later can use them. On top of that, we have also security policies there. So we need to add some configuration in security. So to say, for example, the VNF1 can be accessed remotely from the VNF2 or from VPN for management. We have also the provisioning, because when we deploy a service, it's first the VNFs, it's the networking part that we talk, it's the firewall policies, and also we need to add the users. So we should have the users in place to use the current slice. So we need to have an API, for example, to the provisioning gateway. And of course, we have some other management components there, like the BSS, that we can deploy a slice. So for all of them, we have to develop different plugins and APIs. We try to use as much as we can the open interfaces from the HCNV, like the Sol 5 and Sol 3 that we know. But in a lot of cases, we have proprietary interfaces. So we had to develop several plugins. You see them here in the red color. It's everything that we had to develop just for this project, and takes a long time. It was one of the biggest challenges that we had. So in today's demo, my colleague Tirtha is going to present it soon. So we will see what we have achieved, some of them, based on the interface that I saw earlier. So as the first step is from the digital operation, which is a service orchestrator from Nokia. We will deploy 2 different network services to the NVO using the Sol 5 interface. From the NVO, first, we need to create the networks, because the VNFs will need to use those networks. So first, we have to create them in the SDN. And then, of course, later in the OpenStack, in Neutron. The second major step after the networks is to deploy all these resources from the VNF manager. We have already uploaded the VNFDs based on the Sol 1 Tosca. And then through the HID, we can have the VMs in place. As a last step, we need to show what is allowed and what is not allowed between those 2 VMs. So we go to Panorama API, which is coming from Palo Alto, and then we add those policies there. So once we have the 2 VNFs, and based on the policies, we will see that, for example, we can ping from VNF1 to VNF2, and then we have added that policy in firewall. But the opposite is not allowed. So we block the traffic from VNF2 to VNF1. So this is what we're going to see in the demo. So I hand it over to Tirtha to present how we do it on the service register and also present the demo. Tirtha, please, you can take over.
Thank you, Anthony. Hello, everyone. I'll share my screen. Do you see my screen, full screen?
Very good.
Okay, very good. Thank you. Hello, everyone. So, I need to start my video. Yeah. So, thanks, Antonio. Hello, everyone. So, this is the orchestration model that we are running in VINNI, right? So, starting from the bottom, the horizontal layers are the Telco cloud, the NAV orchestrator, or the Nokia Cloud Orchestration Manager, and then the end-to-end orchestrator, or digital operations software from Nokia, and then the BSS layer. So, and the verticals that you see here, vertical columns, those are the capabilities that each of these layers offer. Now the demo will go through multiple screens. So we'll go in order like this. So we'll have a look at the NSD from the NCOM catalog, then slice pick from the DO catalog, and we'll simulate the BSS and place an order from Swagger UI. We'll be using TMF641 specs for this service order. This order will go into DO and then in NCOM, and then the VNFs will get deployed, and then after it's done, we'll see how information is getting documented in the inventory column in each layer. Finally, we'll also see how the VNFs will communicate using a ping test. Antonio just mentioned. So today's use case is Uber places an order for a slice, which is EMBB slice, and we'll spin up a couple of network services, each having a VNF. So I'll run the demo.
This is the NSD from CBND catalog. Among other things, this is the VNF within it. This is the delivery model from Flow1 catalog. It is a phased approach. In reserve phase, it fetches placement information and records order information in the inventory. In the provision phase, it triggers CBND to spin up the network services. Once done, in the finalize phase, it fetches the NS and VNF details and documents it into its inventory, where it renders an end-to-end slice view. We'll place the order. The identifier is 719. The order is for EMBB slice and is ordered by the subscriber Uber. We will now go to end-to-end orchestrator's order management and do a search. Our order is underway. All the activities are underway. We now move to CBND. Both NS1 and NS2 are being deployed. In the end-to-end orchestrator's inventory, we can search for the subscriber Uber and extend to its topology view. So Uber has subscribed for a video on demand service for large for 1 year. That's the product, and then this is the end-to-end slice with the 719 identifier. If we drill down from here, the information is incomplete because The deployment is still going on. Once it is done, this will feed more information into the end-to-end orchestrator's inventory. Deployment is done. That's how a network service looks from CBND, the VNF and the network service. And from the end-to-end orchestrator, if we do a refresh, information is still on the way. Now it has arrived. So this is the end-to-end slice with network service 1 and network service 2, each of these running a VNF. If we go up, then the end-to-end slice, Uber is the subscriber of it.
Yeah, here now we are connected to the horizon. We are in the beam to see the two new VNFs that have been deployed. We see here the first one. It's a very, very fresh. As we see here, it's just deployed. So as we see here, it's allowed to ping from the one VNF, from the 250.0.2 to the 251.0.2, but not the vice versa. So we see here the IP, the one that we expected. And now if we ping to the second VNF, we will see that this is allowed. We see the correct IP. Now if we try to ping the first VNF, that should then be allowed from the firewall. Yeah, as we see, this is not allowed.
So that brings us to the end of the demo. And for more information around this, as it is. So with that, I'll give the mic back to her.
Thank you very much, Antonios and Tirtha. Now we have a bit over time, but Johan, Morten, have you solved your problem?
Hopefully, I will try to not use video and hope that it works. Should be
Okay,
good.
Go ahead.
Okay. Yes, my name is Johan Morten Tetlie, working at Ericsson in Norway and working with the 5G standalone core. And now we should try to have share my screen. Do you see something?
Yes, very good.
Yes, we can see.
Okay. Yeah. Ericsson, as said, is providing the SA core in the 5G-VINNI project in the Norway site. And currently the 5G core SA is ongoing upgrade process, so we are not able to show a live demo today, but we will show a previously recorded demo by Paul Grunson at Telenor Research. And we will start that in one few seconds. Give me 1 second. Escape.
Hello, welcome to a demo of the 5G standalone implementation in the 5G-VINNI Norway facility site. So the paradigm shift of 5G is about empowering the vertical industries. There are many reasons why standalone 5G being demoed here is needed for this vision. First, it is fundamental to support native network slicing. Second, support for real, ultra-reliable, low-latency communication will come with standalone 5G. Further, there are important features such as support for private networks and edge cloud, to mention some important ones. Here we see all the slices implemented in the 5G-VINNI Norway facility site so far. 3 of them are based on non-standalone 5G, basically using D-core as a mechanism for slicing as in 4G. The focus of this demo is on the 2 slices based on standalone 5G. And it can be seen that slices based on standalone and non-standalone are running on the same cloud infrastructure, using the same transport network and the same radio access network. Here we see the infrastructure, and the NFV infrastructure and the hardware in the cloud is provided by Nokia, as you can see at the bottom here. And the container as a service layer based on Kubernetes is provided by Ericsson. On the top, we see the cloud native functions for the standalone 5G core. And further, we can group these into different clusters. And each cluster is placed into a separate security class so that they can get proper protection and isolation. When building the slices, we instantiate separate instances of the UPF, the AMF, and the SMF, as can be seen to the left. And these different instances go into different slices. And we can also see that the NRF, the NSSF, the AUSF, and so forth are shared between the two slices. In the access part, we started out by using a traffic simulator for testing, and now we have also connected to the 5G G-Node B from Ericsson to both the slices. One major change with 5G standalone is to move into a cloud-native architecture. So let's have a look into the Kubernetes view. So here we see the first Kubernetes cluster with all namespaces in one of the worker nodes. And if you look into one of the namespaces where the second UPF lies, we can see all its building blocks. And further, we can have a closer look at one of the pods in the namespace. And there we see on which worker node the pod is running. And we can also get the status of the resources used, such as the processors, memory, and so forth. And now let's connect the device to the standalone 5G. And here we see a device successfully connecting to the Ericsson 5G radio at Rikshospitalet in Oslo, which is indicated by the 5G symbol popping up in the upper part. And if we look into the operations manager, we can first look at the left graph, where we see that the device registers with the access mobility management function. And you can see how it goes from 0 to 1. And second, we can also look into the right graph that the device establishes a session with the SMF, being the session management function. And you can see how that also goes from 0 to 1. And in the bottom part there, again, we see the Kubernetes pods, which we also looked at in the Kubernetes view previously. Then, here we will show you a packet trace example when a user is redirected from slice 1 to slice 2, in which case the network slice selection function, the NSSF, facilitates this redirection. So, first, we see the initial registration request from a device, which is sent to the default AMF in slice 1. And since the slice ID does not match, a query is sent to the network slice selection function to find the appropriate AMF for the slice. And here we see the response from the network slice selection function pointing to AMF in slice 2. AMF1 then asks the 5G radio to redirect the packet to the appropriate AMF and slice. And then the 5G radio sends the registration request to the appropriate AMF, which is in slice 2. And further, we see how packets are sent to the correct slice. And the last thing I wanted to show you here is Graphana. Graphana is a neat open source tool used to monitor different parameters. And in the upper part, we see the number of devices registered to slice 1 and slice 2, which is counted from the AMF instances in each slice. And in the lower part, we see the number of sessions established to slice 1 and slice 2, being read from the SMF. And what we see here now is that first 10 users registers with the AMF, which you see on the top there, and secondly, they also establish sessions, which is in slice 2. And so this was a quite technical demo, and the next steps now are to provide services and slices using standalone 5G to different vertical industries that we are working with. So a smart port, the Norwegian Defense, Factory of the Future, and a hospital. So please stay tuned for more insight into this. Thank you so much for your attention.
Yes, that was the recorded demo from the 5G SA core part. And with that, I will hand over to Per.
Thank you very much, Johan Morten. So yeah, now we have listened to all the speakers today. Some issues on the way, but we still have some time slot for a discussion. So I'll hand over to Manu to facilitate that.
Sure. Thanks a lot, Per, and thanks to all the panelists and speakers. I think this was really very interesting to see. And again, there's nothing like watching a demo in action and all the sweat and hard work that goes behind it. So really congratulations to the 5G-VINNI team. I have a question around, so at this time, I also want to encourage the audience, if you have any questions, to please share those in the Q&A box or on the Slack channel, and we'd be happy to get the panelists to answer them. I was just curious mostly around RAN slicing. So in this demo, predominantly we saw the core and we saw all the different the user plane functions, the SMF and the slice identity and slice identification up until the radio part. Could you talk a little bit about RAN slicing, or how would a single G node be able to accommodate multiple different slices, and how does mapping of resource blocks, physical resource blocks, match with slicing, and how does that relate to matching URLLC versus EMBB kind of applications? And again, I'm not directing it to anybody. If anybody wants to take it on the panel, please jump in.
Maybe I can start, but I need to transfer the ball to my colleagues. But I think it's a very fundamental question that, to go to the point, we have not implemented in VINNI, but we have been very curious. We are aware from this resource block there's open huge possibilities, and RAN slicing is the ultimate target when we have a 5G environment. We try to work in parallel. Our target was to test things that maybe will be commercial 2-3. So we were 2-3 years ahead when we deploy VINNI. This question come maybe to if we were 5 years ahead. We were this is of absolute interest. To be concrete, this is not implemented, but we have full awareness of the needs, and we have made some steps in that direction. But VINNI didn't. The time span didn't allow, but we have here in the panel experts from Ericsson that may provide a deep insight on this resource block. But in general, that's the short question.
That's great. And I want to ask a question that just came in from the panel, and I think it somewhat relates to my question as well. But this question is asking about, there was mention in this demo about an EMBB slice and a URLLC slice. The question is around, how would you differentiate the two slices, or how is differentiation or different QoS? I'm trying to interpolate from the question that was asked. Were there differences in the VNFs used? Was there a difference in the placement of the VNFs? How was matching the QoS or
yes, there are two
requirements? Yeah, that'd be great.
Very good question. So first of all, when one of the key differentiation in being implemented is by SIM card. So when you allocate a SIM card, we distinguish very clearly if this is enhanced mobile broadband or defense slice or IoT low latency. And when we have these, we can play with different QCI parameters. So that's the possibilities that we have today in VINNI. From a slicing perspective, the short answer is that we provide a lot of redundancy and robustness in the enhanced mobile broadband. Reliability maybe is the key parameter here in terms of failover. So when failure happens, there is redundancies that basically give us very short downtime in enhanced mobile broadband. IoT, in fact, Ericsson can provide better insight, but the modules of the core, and specifically for the slice that will be used for IoT, the core at such have additional modules from the core perspective that Ericsson provide to us. So basically QCIs, but I think that's kind of a well-known business. Second, specific models that Ericsson can provide details, but IoT has specific modules for this. And redundancy is key, and redundancy and capacity is key for the enhanced mobile broadband from the cloud perspective.
Very interesting. So again, apologies, we're running a little bit out of time. So I think at this point, I want to say, if you have any more questions, please type them in our Slack channel to continue the conversation. I want to take this opportunity to thank the panelists one more time. And Stavroula, if you don't mind sharing the slide for the next talk. So in 2 weeks, we will have our next networking channel discussion, and this is going to be about education. So this is global education during and after the pandemic. So if you're an educator, if you're a teacher or a student, it'll be interesting to hear the perspectives and how different educational institutions and personalities and professors have adapted. This is a global panel, so we have representatives from North America, Africa, Europe, South America, and is going to be organized by my colleague Matt Cesar, who's from the University of Illinois. So please join us, register. We will see you in 2 weeks. And again, thanks to the entire 5G-VINNI team, to Telenor, Nokia, Ericsson. Really appreciate you coming out and doing a site visit. Thank you so much, and see you everybody in 2 weeks. Goodbye.